Hello everyone, I'm back with another interesting video of CCNA, that is Network Protocol. So what is protocol? Protocol is set of rules and regulations, so which are combinations by agreed terms by the both parties or the both organization that we're using these sets of rules and regulations that come under a protocol. Protocol can be found and we can see in the airport protocols we have different types of protocols for different countries. So in same way in the network we can define the word protocol with the set of rules and regulations that how data transmit from source to destination and destination to source or to anyone in between the network. So let's start with the network protocol chapter. In this slide, we are going to brief about TCP/IP suites, TCP/IP versus OSI model, common protocols, fields in the IP address, TCP flags or three-way handshake, UDP, common port numbers, and ARP. So let's start it with TCP/IP suite protocol. TCP/IP suite protocol model was developed before OSI model. OSI, that's the Open System Interconnection, is an enhanced version of TCP/IP. TCP/IP is just a conceptual model that defines that how data transmit from one computer to another computer or from source to destination. It's a research and developed by DARPA, that's a GARPA, that's a Defense Advanced Research Project Agency. And these two networks, TCP/IP defines the standard of Internet Protocol. It has four layers in the TCP/IP. We are having application layer, transport layer, network layer, and link layer. Then later on, we're going through with all these layers. But here we're going to understand what is the TCP/IP and why we need it. As we can see in our example, we have two computers, computer A and computer B. So A computer wants to communicate with computer B. So computer A just transmit a signal or send data to computer B that he wants to communicate with computer B. On same way, when computer B receives that signal or data from computer A, if he's ready to continue or he's accept his data packets, he want to make the handshake, he send the acknowledgement to computer B. So we can see the data is transferred from 1 to A or A to B with their mutual understanding or having the set of rules and regulations with the TCP/IP suite protocol. So we can say in the TCP/IP we have main three layers. They're divided into three layers. We have application layer, we have a network layer, and we have a link layer. So what are these layers? Let's understand briefly about this layer, or we can say through with the picture we have the TCP versus OSI, or we have TCP layer, we have application, transport, network, and link. In same way on the OSI we have 7 layers, that's the application layer, presentation, session, transport, network, data link layer, and physical link layer. So the both layer or the both protocols, the TCP versus OSI, we can see the difference. They have a main difference with the TCP/IP and OSI, that the TCP is said to be a transmission control protocol. It's having the 4 layers and is much more reliable than OSI, and TCP/IP said to be a developed protocol than model. On the same way, OSI is developed, that's said to be a model rather than a protocol, and it's less reliable than TCP/IP, and it's having the 7 layers. Each layer have different roles and their responsibilities in network, and OSI is said to be or stands for Open System Interconnection. So we have gone through with the simple briefing about the TCP/IP versus OSI, and OSI has the 7 layer and TCP/IP has 4 layer. Then later on we move with some common protocols including the TCP/IP suites. Of course we're using the TCP/IP, so it has some basic or say common protocol that how the data will follow and how the data will transfer from source to destination. It can be a ARP, IP, ICMP, TCP, UDP, or FTP. In brief, ARP is an address resolution protocol. It's used for mapping of IP address with your MAC address. As you can see in the network, we have the IP address from source to destination computer. On the same way, we need a MAC address to identify the system in network or data wants to go on which system or computer. On the same way, we have IP, that's the Internet Protocol. It's used to deliver the packets from source to destination or destination to source. Next, we have ICMP, that's the Internet Control Message Protocol. As what described, it takes the control over the internet, or we can use for detecting the reports in the network error or used for troubleshooting purpose. Or TCP, that's a Transmission Control Protocol. It's an oriented protocol and used for providing the reliability of your data that transfer from one computer to another computer. UDP, it's a connectionless. It is not secure than TCP. It's a connectionless means there's no session created before packet transfer from source to destination. It just go throw the packet to your destination. The packet can be will not be acknowledged, or just send it and just throw it out of your network to your destination. And same way in the FTP is used for transmission file from host to another computer or another computer to next computer. Or we have a telnet, we have a DNS, we have a HTTP, we have TCP. The telnet is used for connecting a remote connection over the internet, and DNS is used to set to be a domain name system used for mapping of your IP to host or host to IP or vice versa. In HTTP is a hypertext transfer protocol used for transferring your file like video, text, sound, graphics, images over the World Wide Web. So each layer has their own different protocols. As you can say, is an application layer. HTTP, DNS, Telnet will work. In transport, there is the TCP and UDP. In network, we have IPv4, IPv6, and ICMP. In link layer, we have Ethernet, token ring, and FDDI. So this is about the common was the protocol using with the TCP/IP. Next, we can say we have headers in the IP address. What is basically headers? Headers which control your packet, which is responsible for your packet, how the data will send it from source to destinations, with having the predefined their own sets of their ports or sets of their numbers or standards or protocols. Definitely in IP header we have a source port, we have a destination port to form who we send the data, and the destination port to whom we send the data, and the sequence number will be added with the packet for arriving or receiving at the end. So these sequence numbers can be matched at the when data is received, and the acknowledgement when the data is sent, it gives the acknowledgement that data has been received from your destination computer, which gives you the acknowledgement. An urgent pointer will send the urgent flag if the data is in very important factor. It sends the urgent flag. In Windows field used to receive the indicate the sender has the amount of data that is able to accept with the maximum number of packets has been received. So the size of windows measure in the bytes, as we know that. So we learn about the IP header and what are the comes under the IP header category. And next we have TCP flags. As we know, the TCP flag plays a big role for sending a data from source to destination. It works at the back end, but it's not comes to front end to user, and he not will rely with the how this data transfer from one to another computer. Basically, when we send the data from source to destination computer, it performs a handshake process, or we can say in network terminology, it's said to be a three-way handshake. So, what is three-way handshake? Let's understand it with the example. Suppose a laptop wants to communicate with your desktop, as is shown in picture. Laptop simply send a FIN request to your desktop. Hey, this is my request. Are you there? Or just accept my request. I want to communicate with you. When desktop receive the packet from your laptop, if he's received the packets and he wants to communicate with your laptop, he just simply send it back to your laptop in the signal that FIN with acknowledgement. Is just send it back your FIN and gives the acknowledgement, yes, I want to communicate with you. Can we go further? And we want to communicate now. Then again, when laptop receives the signal from your desktop or when receives the data, it gives the acknowledgement to your PC that okay, I'm ready to initiate the connections. In this way, the three-way handshake is completed. It means there's a handshake, there's a mutual understanding between both parties or both computers that we are ready to start the initiate our communication. In the same way, we are using the FIN acknowledgement flags, and we have other flags like urgent, push, reset, FIN, ECE, and CWR. The more important, we are following in three handshake. We have a FIN acknowledgement, and we have urgent. It's said to be indicate the certain data segment should be on the priority basis, so that need to be check on your top of the nodes. And the acknowledgement, it gives the acknowledgement, yes, I got the signal, I got your packets, then go ahead. Then push means it's asked for when your data is going in the buffer mode. When you see in the YouTube, sometimes the slides or our streaming is going to be in the buffer mode. So push will send to record with this problem using the push command, and the RST, that means the reset connection. When connection is not established properly, it will end the connection with your RST. And of course, the scene initiate the connection, and fin will finish the flags. The connection is closed. On the EC and CWR, there's a work at the behind. That's an echo for your signal amount of information to reduce the amount of your information is to send. So this is all about the three-way handshake process, how the data transfer from one PC to another PC. Next, we have a UDP. As you already learn about it, UDP is a user datagram packet. It's unreliable, it's a connectionless, and it's an undelivery of your data. So the same way, TCP/IP header, we have a UDP. In UDP, we have a header like length, source port, and destination port. In length, we have determined the size of the length of the bytes of the UDP header. Source, of course, we need to source port, and we need a destination port that comes under your destination port. So this is all about the UDP. And next we have the common ports we are using in internet, that using as FTP for 21, SSH 22, Telnet 23, so on. That's a DNS 53, SNMP 161, and HTTPS 443. So this is the well-known ports as accepted. If you're talking about ports, let's understand that what is port and what is port number. The port number is the logical gateway of your operating system to carry the data from your sets of rules and regulation, that is a protocol. The port number can be divided later on into three parts. That's a well-known, registered, and dynamic. The well-known is defined by IANA, by Internet Agency, that it should be used for, can be used and for treated as Internet by assign, and these are located with the server services. And the register ports, we have it should be treated as semi-reserved, and we can be used as we can say for some for specific for services in our computer network. And dynamic is a free to use for the client programs. On same way, we can say the well-known ports that range start from 1 to 1023, and registered port 1024 to 49151, and dynamic ports we have a 49152265535. So we have a three types of ports as we gone through with, and we have also a registered port, and we have dynamic ports. In dynamic ports, that's neither reserved for any services and nor used for any, and it can be a dynamic port can be, they are not available for such for registrations, or it's said to be FMML ports and dynamic ports. As you can see, we have ports like 1047 and 1048 that's registered by Sun's NEO object request brokers, and 1026 for Shockspace, so it's registered port. So next we have about the ARP. So what is ARP? As we already heard about, and we have gone through with that ARP is used to provide the mapping of IP address of a MAC address. As we can see, in network we have only the IP address of the packet that comes from. In the same way, we need a MAC address to identify the which packet and where we need to send it by the mapping of their MAC address. It's not about only IP address can send the message to your destination computer. Of course, we need also a MAC address which tells us the package we need to go on which path from which way or to whom, to our destination. So ARP plays a big role in our networking. In a simple way, we can say ARP is used to mapping for IP address to your MAC address. Here in window, we can see what the ARP is running in our system by using a command ARP-A, and then it will show you all your static and dynamic tabs, what they are running in your network and what they are running with your ARP mode. So this is all about the end of the slide about the network protocol. Thank you for watching this video. I hope you like this video. See you next time with more interesting video about the CCNA. Goodbye and have a nice day.